with this problem, what we want to look at is the idea that we can use different substitutions to do the same, solve the same problem. So the first one here, we're using u being equal to 2x plus 7. So we're going to get square root of u there, but u is 2x plus 7, so du equals 2 dx when we differentiate both sides. A half du equals dx then, because we've divided by that. Now we need to get x dx, so we've got dx there. We need to get x by manipulating u equals 2x plus 7. That comes down to x is equal to half of u minus 7. Do our substitution, and we clean it all up here. So the u to the power of 3 on 2 minus 7u to the power of a half. Now we integrate, and then once we've integrated, we can put the 2/5 there, and we substitute the u being equal to 2x plus 7 back in. So, and we get that answer. If we use u squared equal to 2x plus 7, so we've got 2u du equals to 2 dx, or u du equals dx. So we're going to be able to replace dx. In this case, u would be equal to the square root of 2x plus 7, or 2x plus 7 to the power of a half. And x itself would be equal to a half of u squared minus 7. So when we do our substitutions there, so we get the u is equal to square root, so that just becomes u there. We've got u to u is equal to dx, and x was equal to the half of u squared minus 7. Makes it a little bit easier to integrate, because we can get the u squared times u squared gives us u to the power of 4, and minus 7u squared, and then we integrate it from there. Get our integration, which is a pretty simple situation, and then we have our fractions, and we put 2x plus 7 back in for u. Notice that this one's just got an extra 2's being factorized. If we factorize 2 out there, we get a half out the front, so it works out to be the same. So it does. We can use different substitutions there. In this case, we've got a case where we've got u squared is equal to x plus 2 to solve this one. So this one makes playing around with it a little bit easier, because u would equal to square root of x plus 2, which is the bottom one, so that's just going to be u there. X is equal to u squared minus 2, so we've manipulated there to get x, and dx is equal to 2u du. So we're able to do our substitution for dx there, so we make that substitution, make the substitution for the square root of x plus 2 in the bottom, and then x minus 2 was, where were we? We got x minus 2, which is x is equal to u squared minus 2, and we can put that in, and then we've got an extra minus 2. So just got to be careful with that part, because that's a little bit tricky, making sure we get the correct value in there. Got a lot of cancellation happening. We can take our 2 out the front, and we get u squared minus 4, which starts to make it a really easy integration. And then we can start to clean it up when we put the x plus 2 back in to the power of a half with the 3 there, which we get the 3 on 2. So we can clean it up whichever way we like there. Here's the one where we're doing a substitution for a trig function. So if u is equal to 1 plus 10x, du would equal x squared dx, so which is what we see on top. So that just becomes du. 1 plus 10x is u, so we get u cubed there. Makes life easy when we integrate, so we add 1 to the power, divide by the new power, and then we do our substitution back in, and then our constant integration. In 10 here, again, 3 minus 2x, that's 2 sine x, so du is minus 2 cos x dx, so we've differentiated both sides with respect to their variables. Minus a half du then, because we factorise that, we divide by the minus 2, and that gives us a cos x dx, which just happens to be the numerator, and our denominator was this function here. So again, we're just going to integrate 1 on u, which integrates to a log function. So again, be careful when we're integrating, because we're going to integrate to a log function there, and then we can see that we get log of 3 minus 2 sine x. And we can see with the next one here, du is equal to tan x in this case, so du would equal x squared dx, which we're able to do a substitution there to give us du in for x squared dx. U is tan of x, so we get u to the power of 7, which is a very nice integration. And we can see that this is all really just a reversal of the chain rule. So if you're not sure about any of them, differentiate your answer. If you differentiate your answer, you should get back to what you take the integral of in all of them. So there's how we do our substitution. And it get a little bit harder, and we got some trig coming, or we can use different types of functions as we go along.